You'll probably get a little note. All right, so we're recording. So welcome, folks, to the, I guess, second tech talk of the quarter. This is co-sponsored with the TAO, and we are doing something a little different this quarter. The last three tech talks of this quarter are going to be about centers and institutes that EECS is involved with. So people can hopefully learn a little bit more about what their roles and purposes are, and know if it's relevant to you. So for example, today, hopefully some of you will see potential connections to CASS. Next week, we'll be talking about NASC, which is the Northwest Alliance for Computational Science and Engineering. That's actually in 2 weeks. And then the final week of classes, that'll be in about a month, we'll talk about the AgAid Institute. So that's what we have in store for the rest of the quarter. But today, as you can see from the screen, we're going to tell you about CASS, which is a really great center that we've had here for quite some time now. It's gone under different names, but the students get tremendous experience. People actually get great software and services from CASS, including the state. ODOT works with CASS a lot. You'll be hearing some about that, I'm sure. And we've got two members of CASS who, as I understand it, started as students working in CASS, or whatever it was called at the time, and have now become leaders of CASS. So we're very happy to have Carrie Hertel. She's the CASS director, the acting director, and the director of software development group in CASS. And we have Mark Clements, who's the software development and QA manager in CASS. And they're going to do a tag team. I think Carrie's going to start first, and then Mark will round it up. And we'll so if you do have questions during the talk, please, you can put them in chat, and I'll kind of watch that, or you can unmute and ask if it's something that needs clarification, and we'll have time for questions at the end as well. So without further ado, I'll turn it over to you, Carrie.
Okay, thanks, Alan. Yeah, Mark and I are both Beaver alum and basically started here as students and never left. So as Alan said, I am the director for the software development portion of CASS. I've been here about 18 years now, and that is only staff time. That does not include my student time. I do have a BS in electrical engineering here from OSU. I started out as a test engineer and basically, like I said, never left CASS. I do a lot of project management, administrative types of oversight, as well as some business analysis and testing. And with that, Mark, do you want to do a quick intro?
Yeah, sure. So as mentioned, I'm Mark Clements, a senior development QA manager at CASS. I actually started off as a student developer, helped create the software development group, working with a staff member when I first started as a student. And I'm going on 20 plus years now, full-time staff in the software development group itself, and really enjoy it.
All right, so today I'm going to be sharing with you a brief intro about our program, and then I'll turn it over to Mark, and he's going to go over the technical stuff. So let's go ahead and get started. So to start off with, I just wanted to show our mission because that is the reason of our existence and it's really important to us. We are a self-funded program and we are supported by the School of Electrical Engineering and Computer Science, and of course the College of Engineering is part of that. And our mission, experiential learning for students. How we do it is projects that we do for clients. So we're going to talk a little bit about the structure and how we do that, and then Mark's going to give us a real world example. So what is the recipe for success? So we have our CASS professionals. They assist with the institutional knowledge and provide project oversight. Our students who need experience, and customers who need the projects done and would like to contribute to our mission. Put that all together, run it through CASS, and what you get as an output is some work-ready students. So these students learn technical and soft skills. They get to know our customers for potential hiring down the road, and our customers get quality projects completed and overseen by our staff and worked on by the students. There are 3 groups, which Alan kind of touched on a little bit here. So we have 3 areas in CASS. SDG, the software development group, mostly do custom web applications, but we really try to fit the technology to what the need is. So it just kind of depends on what our clients' needs are. Build new and or can provide maintenance on existing applications. The test lab have a history of providing assistance to companies on how to do good testing. For example, we've helped a startup mature and grow. They had almost no testing. It was very much by the seat of their pants developers testing, and we were able to get them onto a test cycle and actually do some automation and things like that. We used to have a large lab of networking hardware that we tested doing interoperability and power over Ethernet. The open source lab, they are well known in the open source community. They often can provide a neutral territory for hosting, and the students are really sought after because they get that DevOps skills hands-on with hardware and clients, not something that your average student gets to play around with. Our team here, so Carrie, Hertel, you know me, and Mark, Bharatwaj Appasamy and Patrick McGraw are our other 2 professional staff developers. Lance Alberson is the director for the open source lab, and then Pam Bielenberg, our very important office manager, supports all of those background kinds of activities. And then we have anywhere from 20 to 40 students at any given time, just depending on the project load and what we have for staff available. So I wanted to show a little bit about how working with our customers truly benefits our students, since that is our mission. Hands-on experience, the students gain some hands-on experience while they're in school, which helps them support themselves financially. This is a paid internship that they get to do. The projects we work on have, real deadlines and specifications, and they get to experience the full software development lifecycle as part of that. Teamwork, communicating and engaging with each other, and customers to solve issues and fulfill requests. The soft skills, this is one thing I think people forget about a lot of times, but it's a very important thing for them to be that work-ready student. And this is to learn how to work. So using tools like Teams, Outlook, calendars, they have to do meeting requests, learning what it means to be part of an agile software team. These are all skills that those of us who have been working in industry for a while, we take that for granted. So it's a great training ground for them on that. Our customers, so establishing a relationship with potential employers while they're still in school. So that's very valuable for our students. Our graduates are very highly sought after on the job market, partly because of all of this experience that they get, right? Mentorship, we have about a 4-to-1 student staff ratio, and most students are here for at least 2 years. We require at least 1. We've had some as long as, I think I had somebody who stuck around for 6 years, to which I told him, you should probably graduate and go get a real job. But he was here for quite a long time. And having that amount of time helps them get up to speed, really contribute to those projects, and it gives them some adequate mentorship and career development experience. So a little bit about the ODOT partnership before I turn this over to Mark. I just wanted to share a little bit of how CASS partners with them to kind of set the stage for the technical discussion. So CASS team works in concert with the ODOT team. We do shared workspace via Teams, and we do work item tracking in Azure DevOps. And Mark could touch more on, I guess, Visual Studio and all that fun stuff. My little cogwheels here. So the project concept is we work together on scoping and estimating the project. It's very much a collaborative effort with ODOT and their users. Software development and test. So CASS provides the software development for the most part. I think ODOT helps a little bit here and there. CASS and ODOT partner on the test planning and the execution. And that little cogwheel, being green and the little one, actually spins on for quite a while in the project. Doing the iterative agile development, there's quite a few iterations that'll happen before we get to that big red cogwheel, which is the release and maintenance. So release and maintenance, CASS assists ODOT in the software release and support. CASS also assists ODOT in maintenance requests over the life of the project. So in the case of the project that Mark's going to talk about here, the ODOT home screen, we've been working on it and helping them maintain it for at least 10 years now. So it's been kind of a long partnership. And with that, Mark, I think we're ready for you. And
all right,
there you go.
I need you to stop sharing real quick. Here we go. You should be seeing my wonderful slide here. All right, well, thanks, Carrie, for that wonderful introduction for ODOT. And I think what I wanted to do here was to dig in a little bit to a specific project to give you a sense as to the type of experience that our students get exposed to when we have wonderful partners like ODOT working with us. And in particular, this home screen project is a long project. It's more than a year long once it's going to be done. We are only in maybe the first third of the project right now. So we have another year to go before it releases roughly. And in this particular project, we're helping ODOT kind of begin to migrate their architecture of a very important tool they use, which we'll talk about a little bit today. And so I'm going to end up just briefly touching on the concept of monolith versus microservice, because I don't want this to be a talk about microservices. There's plenty of information out there, tons of hype going on, so we're not going to talk a lot about sort of the technical details there. We're going to more focus on specifically how are we applying this approach to this product that we've been helping them develop and maintain for many, many years, and the impact that's having in terms of the student learning that's going on. So we'll briefly sort of just touch on monolith versus microservice, just so we're all on the same page. We'll get into an introduction to something called the Transportation Operations Center system. And that's this, again, kind of major product that we've been working on with ODOT for years and years. We'll talk about why we chose microservices for talk specifically. Why did we even start going down this road? And we'll give some real world examples of how we're breaking up that monolith. Like, what are some actual services that we're breaking out and turning into microservices, and you know, what have we been learning as we do that? And then we'll also cover some lessons learned so far. And again, we're only just getting into this major project, so there's a lot to be learned yet. So with that, just to get us all on the same page, a monolith is essentially an application developed with all of its components running within a single process. And that single process can be scaled out by duplicating the entire monolith service across multiple servers. But you really, because it all runs in a single process, that entire monolith has to be replicated if you want to do that. And there's some benefits to that, but there's also some difficulties as it comes to those monoliths, especially as the system itself becomes more complex. A monolith can be a real detriment in the end. And then microservices takes an approach where we, instead of dividing up based on sort of modular components within a single process, we now actually take those components and break them out into their own individual services. And then those services can be deployed and scaled out independently across machines if need be. And that gives you some more flexibility. However, it comes with a complexity premium that goes with that. And I actually find myself often agreeing with a lot of what Martin Fowler has to say. So I kind of borrowed some things, in fact, this model of his, and really like this idea of a microservice premium that he posted about, in that, ultimately there's a complexity cost to them. And if your system is too simple, well, you're going to be paying too much cost for that how simple the system actually is. In fact, he even suggests maybe some applications should start off as a monolith, and then eventually, as it becomes more complex, and as you kind of cross that barrier of where it becomes worth it, then start to work on breaking things out into microservices. To me, I kind of distill that down to this idea that, hey, before we ask if we can do microservices, maybe we should be asking even if we should. And I think part of the story I wanted to share with you all today is this idea behind, well, for TOCS, why did we decide we should go to microservices? But I did want to briefly introduce first the actual application itself. So the Transportation Operations Center system is a built from the ground up solution to a dispatch need. So if you can think of like 911 centers where folks make phone calls to get emergency services, and those dispatchers take those phone calls, record the information that they're receiving over the phone, and then they disseminate it out to the various services or various responders that need to know that information so they can go and respond. Well, ODOT operates their own dispatch centers. They have 4 of them across the state of Oregon. There's one in Portland, one in Salem, one down in Southern Oregon, and one over in Central Oregon. There's actually a fifth one that operates kind of part of the year in Far Eastern Oregon as well. But those dispatch centers, those dispatchers are responsible for this process of gathering and disseminating information. And they use computers to do that. And a tool built for that is called a computer-aided dispatch tool, or CAD tool. Not to be confused, of course, with computer-aided design. So these CAD dispatch tools really help a dispatcher kind of see information about what's going on, quickly record information, and then also, again, then disseminate it to others. And we've been working with ODOT for several years, developing, like I said, from the ground up, this computer-aided dispatch tool. At this point, the vast majority of the lines of code within the TOCS system have been written by students here at Oregon State on campus and through eCampus as well. So we continue to partner with them to add features and enhancements every year. And we have typically multiple projects with them developing this tool. One of the things that we found, and one of the reasons this home screen project started, was that the current design, as you can kind of see depicted behind here, is very old. It was developed back in the 90s, actually, and is not super flexible and not very configurable. And we found that because they have dispatch centers in disparate regions of the state, and those dispatch centers have different needs, even though that the current dispatch tool is a statewide tool, they still have kind of their individual requirements based on their geographic areas. So Central Oregon, with all its weather and closing of roads due to ice and things, is a very different set of needs than, say, in Portland, where they deal with a lot of fender benders and a lot of congestion and traffic. And so the system is somewhat unique amongst CADs in that it's statewide, but that presents its own issues in the sense that we've got disparate needs across different geographic regions. So we wanted to come up with a new home screen for them to help alleviate that, develop a new, more configurable tool that would allow each of the centers to be able to hone the home screen to work better for their individual needs. So we started looking at the home screen as an opportunity for us to start to break up the monolith into smaller services. So we chose to go microservices, and students have been a part of this process and have been learning about these kinds of decisions because we incorporate them into discussions and meetings with ODOT, as well as internally discussions around these things to try and help them envision this same process, which really makes a rich learning experience for students here. So one of the things we found is that defining boundaries within a monolith is a very difficult thing to maintain. Over the years, especially as students come and go, and you've got lots of people who worked on these projects, it's hard to keep those components nice and decoupled. It's really easy because they're all just sort of wrapped up in the same application to break those boundaries. And so over time, technical debt builds up as those boundaries tend to blur some. We've also have only a certain time of year we can deploy between April and October, because as winter hits, the dispatchers become so busy, they just do not want to touch the TOCS tool. So they try to keep things stable over the winter months. Well, that means we only have a certain amount of time we can deploy within. And due to the monolith, we don't really have the ability to quickly deploy, because we have to deploy the whole application. There's a lot of regression risk when we do that. And that means that our testing cycles, which again, currently are all manual for the most part, when it comes to regression testing, they end up with this long deployment cycle wrapped around this big monolith that they have to make sure it all works. And that means we can only get 2 to 3 deployments a year. And that's a real issue for them, especially as they want to release individual features. It's really difficult to do that on the monolith. Of course, there's a scaling challenge, as was talked about early on, in that it's difficult to scale the entire application. And so they can't really scale individual pieces to support where they're, the particular business needs that are need higher performance. And then because the monolith has all the data stored roughly in a single database, there's a lot of database conflict and transactional pressure on that single database, and that creates some issues for them performance-wise. And then there's a technology stack interdependence amongst the components because they're all within the same application. Currently, that's the Microsoft .NET stack using the .NET framework, which is now sort of a deprecated stack, essentially, because the .NET framework 4.8 is our last version. And then we're supposed to be moving forward to .NET 6, which is an open source cross-platform .NET stack that Microsoft is switching to. And we're kind of stuck now on that 4.8 version, and we're hitting a roadblock there. And we need to be able to break out services so we can start building on the new stack and not have to go and just upgrade the entire monolith all at once. So those are some reasons that we looked at that really suggested to us that microservices and the premium that we would pay for the complexity of the overall system was worth the cost in the end. So how are we actually doing this? What does this actually look like? And this is just an overview of sort of the old system here, kind of in this orange maroon color. We've got the monolith, which is a set of services on, again, .NET Framework using something called Windows Communication Foundation. And that's where pretty much everything happens today on their kind of middleware. So all their business logic and processing happens within components that are wrapped up in this single application. They've got various different clients that connect and use those services. And the home screen project is actually one of the first areas where we're starting to break things out. So currently they have a thick client, a Windows client, and we decided that we wanted to start to break that apart. And we've been doing that actually for several years now, where we've been, instead of developing new forms on this technology, we're taking advantage of a .NET capability to where we can embed essentially what's the equivalent of an iframe and then dump web front-end components into the Windows Forms platform components. And that allows us to break up the user interface into smaller chunks of applications. So we might have a screen that actually isn't a part of the Wing GUI. It's actually a whole separate application that just gets presented through an embedded web browser. We're currently using a fairly new release of something called WebView 2 from Microsoft that enables us to do that using the Microsoft Edge engine. So it's based on Chromium. And that enables us to take advantage of sort of modern HTML, CSS updates, as well as continually updating Chromium updates that help keep things secure and whatnot, and give us a little bit more capability in that web little embedded browser that we have. And so the home screen is going to end up taking advantage of that, where we're able to independently construct the new user interface application without affecting the current GUI until we're ready to actually embed it and put it in there. And so we've been able to develop fairly independently the new user interface, which has been a real big benefit for us. So that interface is going to require some sort of backend. And we've been utilizing an architectural approach for microservices called a backend for the front end, or a BFF. And so we create a gateway, which becomes sort of the best friend of the home screen UI. And that gateway is responsible for pulling together all of the data from the various services on the back end and pulling it together in a way that's going to best meet the needs of the user interface itself. So that gateway we're able to build again as its own separate application. It's built on the .NET 6 stack using ASP.NET technologies for things like Web API, which gives us the ability to do a REST API in here. We've also used some open source technologies for doing GraphQL. So we have a GraphQL capability here for profile data, for example, that allows us to can take advantage of these more modern capabilities, again, without being stuck inside the monolith and being stuck with the technologies and that stack. Ultimately, that gateway needs to know and be able to update all of the data that it's got sort of cached and housed. And in order to communicate updates and keep the gateway up to date for the home screen UIs to be able to be current and up to date, we've started using Message Broker. For this, we've been using Apache ActiveMQ, using their latest Artemis version, which is an open source message broker technology, utilizing a standard AMQP protocol so that if we did need to swap out broker technologies at some stage, that would be a fairly straightforward operation to do. Again, it's its own separate component so that we have again, part of the reason for the message broker also is to decouple things. So instead of the gateway having to know specifically about this reminder service, where it lives and how to call it, it can simply put messages on the broker or receive messages from the broker and not have to know even where it came from. So that message brokering allows us to decouple these services from each other and more independently scale, update, and change those services potentially. And then we've got some of these services, and we're going to talk a little bit more about these two services and kind of why we chose those as an example of, how we can dig into a monolith and what are some good sort of first services to pick as you start to tackle, say, breaking up a monolith. And, one thing we've been able to do with a really great partnership with ODOT is take all of this complexity and apply students to solving this problem. And so students have been a part of this path for us this whole time, working with us to help devise the architecture so they get exposure to how we break up monoliths and how we do microservices. And they've been learning along with us in terms of exactly what are good ways to implement these services. And then, of course, they're doing the hard work of actually getting these things all built out. We've been able to do some interesting things too, development-wise, to get students a breadth of experience, which we'll talk about a little bit later too. I think one other thing from a microservice perspective that's really important is drawing a bounded context. And so you'll see here that as opposed to this approach with a monolith where there's one database and everything sort of relies on that single database, each individual service is solely and wholly responsible for its piece or its business opportunity. So this reminder service, which again, we'll talk about here in a minute, is solely responsible for all the reminder data. It's not a part of the monolith database anymore. That allows us to use whatever database technology is best for that particular problem. And also allows us to, make changes to that without having to affect maybe other systems that rely on that same database. And it's important, I think, in a microservices pattern to make sure that you've drawn those strong boundaries and you don't allow things, for example, to connect from, say, one service to a different database and cross those boundaries at all, because you can end up with essentially a complex monolith in the end. So that's one thing to take away here is, from a microservices perspective, we've found it's been very beneficial to keep things very compartmentalized. So how did we pick a couple of these services? Why did we choose those? In the TOCS system today, there's a pretty minimal profile customization capability where they can go in and define a profile, and they have some settings, but it's not super robust. All of that data, of course, housed in the monolith and a part of the monolith database. The complication was the nature of the structure of that data and the fact that it was all embedded within the monolith was going to make it difficult for us to expand the capacity of and the quantity of profile customization data that we had our dispatcher storing. And when we started looking at wanting to customize the home screen and give them a lot more options for how they can choose to customize everything from the width of a column to the sorting of a grid, to the size of the grid, to the layouts of the grids themselves, there was going to be a lot more profile data and not data they could even necessarily go to a separate screen to set. We need to be able to save and store that profile data in a much more robust way. And we saw profile data as a fairly encapsulated already module in our monolith. I think that's one of the key things to look for is if I have a fairly well-defined component in the monolith already, that becomes a fairly low-hanging fruit to break it out into its own microservice. And we definitely for profiles found that this was the case. But because it was already fairly well compartmentalized in the monolith, there was going to be fairly minimal impact to the monolith when we extract it. And the service is going to be capable of really expanding the quantity of data we're going to have. Because ultimately, if we kind of look back at the architecture here, this profile service now has its own database, and we're ultimately going to be able to use whatever structure works best for profiles. In our case, JSON data turns out to be a lot more robust and extensible for expanding the quantity of profile data that we have, and we can use a data store that's really specific to working with that, as opposed to having to be stuck with the relational tables and structure that the old monolith used to store profile data as. And then this reminder capability is this little feature on their home screen in their list of events that they have. They have these little icons that kind of indicate to a dispatcher, hey, there are some pending actions that have not been performed on this particular event that you should consider performing. So perhaps, for example, an event has not yet been disseminated to the public through chipcheck.com. and they have a special way that they can post an event out there so it shows up on tripcheck.com. Well, we'll show after a certain number of minutes, we'll show them a reminder that says, hey, you haven't posted this message out to TripCheck, and yet it matches the rules where that should probably have happened. And this is going to help dispatchers not lose track of especially when they're really busy and they've got a lot of things going on, not lose track of some of those key things that they need to do. Today, that logic is all wrapped up in the user interface itself, and it has to pull across all the events and do a bunch of calculations, and it's just a lot of local processing to kind of make that all work. And there's a lot of data that the client has to go sort of grab and keep up to date in order to make all those decisions, because it's kind of making those decisions on a polling model. Well, moving forward, we wanted the ability to be able to be event-driven, right? Using a more event-driven approach where anytime a monolith changes an event, we could take that changed data and evaluate it and determine what reminders might need to become assigned to that event immediately upon the change, and be more sort of pub sub driven, if you will. And also remove the logic out of the UI itself and put it into its own little service that could be solely and wholly responsible for the management and processing of those reminders. And then that information can be communicated back to the gateway and out to the client using our message broker. And so that service, again, because it was fairly compact and already in a place where we could easily sort of create a bounded context around it, was a fairly low-hanging fruit and something that we were able to utilize to enhance our ability to increase the types of reminders and improve that feature moving forward, and do so in an independent way, because we can release the reminder service without having to release the monolith and everything else potentially. So that's been a good service for us to pull out as well. So there's a couple kind of real world examples of some services we've broken out. So what have we been learning so far? Certainly there's a lot we have to learn yet. We have not deployed this to production. We've not accomplished, a year or 2 years worth of this being in the wild, and how hard has it been to maintain and manage it. So there's a lot of, I think, difficulties as well as opportunities for improvement that we're going to be seeing as we move forward with this project. But even up to this point where we've really just gotten started doing this monolith breakdown, we've definitely learned some things. One of those is that the development environment complexity definitely is one of those complexity premiums that we pay for microservices. And you can kind of sort of see depicted here. If I want to run the application end to end and kind of see, hey, is everything playing and working together the way it's supposed to? So where I could go to the old home screen and make a change, and then on the new home screen see that update occurs. I have to run a ton of little applications. I've got to get the development environment to start up all of the various services that I need. So when I start up, I got to have this service and this service and this service and that service and the monolith itself and the Wing GUI client start, and all those have to start up all together in that development environment for me to make it work. And so that's been a bit of a learning curve for us. And it's Visual Studio and some of the tools in VS Code as well both make this fairly straightforward. So it's still press a button and they all start up. But it certainly took some effort to get there. The other lesson we're learning is that trying to get to a robust DevOps capability is not an easy feat. Strategically, it's difficult to take time away from active projects and putting out fires to grow your maturity around DevOps is a hard thing to do. And so we've been finding it really difficult to sit down and actually build out pipelines and learn how that's going to work within the ODOT environment. And because they're mostly on premise. And so a lot of the automation has to happen through the pipeline and deploying local on-prem servers and carving out time to hone that and sharpen that skill has been really difficult to do. The other thing we were finding is that defining these boundaries is also fairly difficult. Trying to identify, services that, are bounded in a correct way that minimizes their impact or their interdependencies amongst each other has been difficult. Trying to define the message flows within the message broker and making it, minimizing the interdependencies between the service and in particular with the monolith from where they originally were broken out from has been, a difficult thing to to accomplish. And it's taken many iterations to try and get to that stage where we know where the service kind of gets to a good place ultimately in the end. Now, with those difficulties, we've had some definite benefits we've seen. And so far for us, microservices has definitely been worth it, and we haven't even gone to production yet. One of those benefits is that the developers are seeing more development tool independence. They don't have to develop everything in one IDE. Because the services are now fairly independent and those technology stacks can be selected based on the nature of the service itself, they can also use the development tool that works best for that particular technology. So in the front-end UI, for example, for the home screen, we're developing using Vue.js, Vue.js 3, and they've found, several of the developers, that VS Code is a better development tool for developing Vue apps than they've been finding in Visual Studio natively. And so they've been able to develop the home screen UI code using VS Code, even though the rest of the services, maybe are better developed within Visual Studio itself. And so because of that independence of the applications, we have that flexibility of the tooling, not just the technologies. And then, of course, there's the technology independence as well. That's been really beneficial for us. I think another thing that we've found, and from a learning perspective for students, this has been really beneficial, is that we can, because these apps are independent and have different technology stacks in them, we can have students for a time work, say, on the middleware and the gateway, or work for a time at the reminder service, but then be able to cross-train. So pair up, mentor with, and then switch teams to begin to develop new features, but at a different layer. So students who started off doing backend services can switch and start working on front-end Vue code, and students working on Vue would then switch and work on backend. And it's been great for them then, because they get this rich experience where they can switch and get kind of a full stack experience, and really learn about, well, what technologies do they feel like they like best, where do they feel like their skills fit best, to help them kind of hone their career, but also give them a good breadth of experience and hone their skills depending on to better prepare them for the workplace in the end. So that's been a really great learning opportunity for students, having that independence. And then the deployment flexibility. So, as I mentioned, we can only deploy applications sort of a couple times a year currently because of the time frame it takes to deploy them. But even this early on in the home screen project, we had a situation where we had started the home screen project already. And typically once we start developing, especially if we're modifying the monolith, it's very difficult to change order and be agile enough to adjust and change. Okay, well, we're not going to release this next. We're actually going to release this other feature next. And ODOT had this opportunity to connect to the Portland Dispatch Center Consortium, which is a group of dispatch centers up in the Portland area that kind of combine forces from a technology perspective. And this includes folks like the Portland Police and other 911 centers up in the Portland area. And ODOT interacts with those folks, but today they do it all by hand. They phone call or email. And they really like to be able to have the CAD systems interconnect. And a grant came available, but the grant required that we connect to their system within, by I think it's February 2023, which meant we had to release, again, because that's the middle of the winter, we had to release by this year. So we had to get that solution deployed and implemented before October this year, which meant that we couldn't deploy the home screen in front of it because home screen wasn't going to be ready in time. Well, because, again, the architecture enabled us to develop things very independently, we were working all out in this space out here, we could start working on the PDCC CAD solution and do so immediately and even release it ahead of the home screen, even though we'd already started developing the home screen components, because we were developing independent microservices, not making significant changes to the monolith. We've really had such minor changes to the monolith that we can simply release the CAD PDCC solution ahead of time. And then the CAD solution itself is going to end up being its own microservice. So even we're able to develop somewhat independently and get started a lot more quickly without having to impact other releases like a maintenance release that we're currently working on the monolith itself. So we've really seen a benefit in the deployment flexibility even before we even get things out into production, which has been great. We're also pushing the DevOps automation world with them, right? We're having to flex that muscle because we have to. If we want to be successful at microservices, we can't be manually deploying all these services. It's too complex. We got to be able to do that. And so we've been sort of forced with ODOT to get better at that. And that's a really good motivation for them to put some resources towards it so we can work with our ops teams and really ensure that this DevOps automation capability is going to be successful for them. So that's both a difficulty, but also going to end up being a long-term benefit for them in the long run. And of course, we have a lot to learn yet. So we'll see how this goes and what more learning opportunities come out. But I think the huge advantage that CASS has been giving students here is that they get a window into all of this. They get to see, how this breaking of the monoliths is working, and not only at the rubber meets the road level of just developing the services themselves, but also running into the difficulties and learning about those difficulties and helping us overcome them all along the way. So ultimately, a really great project for students to learn from. Very, very rich learning experience. So in summary, of course, while we have a lot more to learn, we think, and a lot more remains to be seen. Thus far, the microservices approach is definitely proving itself to be worth it in the case of talks, that it is complex enough that we're going to see some benefit there, and we're already starting to see those benefits. And we're excited to see the learning opportunities this project continues to provide students. And it's all, of course, due to partners, great partners such as ODOT providing us these projects. And Carrie, I'll give it back to you. I think that's all I have. If there's questions, we're happy to answer any questions as well.
Yeah, I think we're just ready for questions. Alan, I don't know how you guys normally wrap these up.
Well, usually, yeah, we open. Yeah, thanks a lot. This was really interesting for me. I don't think about software at this level very often, so it was very interesting to see. Yeah, so we have time for questions now. Anybody can unmute and ask a question or put it in chat. I have a few questions. So I'll just start with one at least. I've got some that are technical, some that are about students, but I guess I'll start with a technical one. So Mark, I know you have something to do with the quality assurance at CASS. So when you think about microservices versus the monoliths, are there any, what are the testing challenges with each of those? Do you have a preference if you were just trying to maintain quality?
Yeah, well, so certainly unit testing is a big part of what we do. So we actually push our students to do test driven as much as we can. It's a very difficult discipline to maintain. It's really easy to want to just go solve the problem before you write the test for it. But with every microservice, we in fact, I can just pull this back up. With every microservice, we have a test suite that goes with it that validates, from a unit test perspective, that its functions are working the way that they're intended to work. We do, in that unit testing, we do use dependency injection or inversion of control, right, as a way to, we don't actually have a database for those unit tests, so we mock that. So we mock those dependencies that sit outside that service, and we really just test that the service itself works. Those tests are the kind of tests that would help us evaluate on a regression perspective, that if we were to, say, make a change to that service, update the test for the new feature, we can make sure that all the existing features aren't broken, and do so quickly through continuous integration. We could see that those tests get executed in an automated way and validate, hey, that service and the way it interacts in, the previous features were implemented were not, broken. So unit tests and don't necessarily provide a ton of out of the box benefit on the first go of a service being built out. They do pay their dividends in the long run, right, in terms of being able to regression. So that's definitely something we do on a regular basis with these services. That gets a lot more complicated in a monolith. Writing unit tests really depends upon really good, strict adherence to componentization within the monolith itself. And we've found that over time that breaks down real quick. Whereas with these individual services, they're small enough and compartmentalized enough. And again, we don't have a lot of experience with them yet. We're only just starting down this road with ODOT. So remains to be seen, but we feel that it's going to be much easier to keep those tests up to date. Now, that said, the integration testing that needs to occur to validate, hey, do all these interconnections work? So if I was to change an event and the monolith was to put a message on the broker, does my reminder service pick up on it, evaluate it appropriately? And the evaluate part's the part that's tested, but not the fact that the message made it and that the database made it to the data. Well, that integration testing is much more complicated. And for now, the way ODOT handles that is through manual regression testing. So we would rely on a test that they write at the Carrie's QA group, for example, will go in with student analysts, develop actual manual tests for the home screen that require you to go in, make a change to an event, see that it actually populates on the home screen. And the expectation is, well, these connections all have to be working for that pipeline to work. And that's how integration testing is working. So if I had my druthers with ODOT, they'd give us the time and money necessary to develop more automated integration tests where we could not have to rely solely on manual testing. And I think that's an area they're going to see as microservices grows. Just like DevOps, we're going to have to do that because it's going to become untenable to do it all manually. So, I would be thinking from an integration test perspective, how can I automate some of these message flows, for example, and know that the message flow is working even without necessarily the UI involved? Does that make sense?
Yeah, definitely. That's what was coming to mind. The interactions of these
right.
processes. That's the scary, but the most useful aspect of it, but the hardest thing to tame, I guess.
Yeah, and the things that keep me up awake at night are things like, well, what happens when the message broker goes down, and how does the system handle that, and how are we going to test that happens? How are we going to do that? Well, the way we're going to handle that with ODOT is we're going to do a manual approach to that. We'll actually tear the broker down and then see how it recovers when we bring it back up. And we'll have a manual test written up to do that. It would be great if we had a more automated way to do that. But it requires upfront investment that often the business isn't so keen on paying for, is the issue, because they don't see the initial advantage of an automated test when you build it. Because as I'm building out this stuff, it's changing. I'm constantly changing the test too. Well, that's extra cost, which won't pay dividends until I start regressing later. And that's the difficult sell.
Right. Yeah. So I don't want to hog all the question time. So does anybody else have a question they'd like to fire out? Give you a few seconds here. Okay, well, I'll ask another one. So if we think about, I guess this is about the educational aspect. So I guess I'm curious about what is the onboarding process like for a new student, and are there, like, going in, do students have particular roles that they go into, or one might be a tester, one might be a backend engineer, or do you sort of find that, and it might be fluid as they progress? So onboarding and then specialization, I guess, is what I'm curious about.
Yeah, Carrie, you want to take the onboarding part and I can talk about the specialization part?
Sure. Yeah. So when we interview the students, we usually have some projects in mind, and most students come in with some technologies and things that they're comfortable and familiar with. And we do kind of a matching process. I also talk with them about, what do you want to learn? What do you want to get out of the experience? And try to find a project that can help them grow in that area. So onboarding generally looks like you come in, you get your email, all that typical stuff, learn how to clock in, all those kinds of things, get your schedule set up, and then you go into some training phase. So we have anywhere from a week to sometimes into a couple months, depending on the technology space, that they will spend doing some training and working with their peers and working with their mentors to get up to speed. And then we bring them into the project.
Mm-hmm. And are those training sessions, do you sort of have some of those scripted for particular technologies, or are they sort of related to what's going on at that moment?
Usually they're technology focused, and we find there's a lot of, especially the LinkedIn Learning that OSU has licensing for, there's a lot of great stuff out there. And so we will kind of partner them up to, hey, you don't have C# experience, projects you're going to work on has a ton of C# in it, go do these training exercises, and have them, spend the time and then kind of reiterate back to us what they've learned and start to try to apply it.
Mm-hmm. Great.
Yeah, we also assign both a staff and then as well a more senior student as assigned mentors. So they have specific people that they are working with, that are pairing with them to kind of shepherd them along that training process and help prepare them for the project that they're going to be working on. And we don't expect through the training process that they'll be like instantly ready to develop well on a project. So typically a newer student will spend a lot more time pairing with staff or another student mentor on a project to kind of get their feet underneath them. And then we'll start assigning them tasks where they can work more independently as they've kind of gotten more ingrained within the project itself. And then in terms of the technology stacks and kind of how they specialize, we try and not let them specialize too much for too long. We do our best to want them to stretch. So we meet with students once a term as best we can. We try to keep that schedule so we can kind of get a sense as, okay, how have things been going? What have you been working on? And what are areas where you want to grow? And where could we switch you to get you to grow in that other area? And that's where I was saying, for example, we are able to do things like, take them and have them do backend work, but maybe they switch and do front end work, or maybe they switch to a whole different customer and work on a whole different technology stack, for a while. And then the staff are able to sort of keep the continuity and maintain the continuity as we shift students around between projects, or between, front and back end or whatever in terms of their abilities. We do also have a specific role for student analysts where we target not just CS students, but also BIS students coming out of the College of Business to try and give them analytics opportunities. And that's where, for example, Carrie works with them on doing, creating and running manual test cases, managing requirements and a backlog, writing vision scope documents, and doing some of those analytical things that they might be targeting for their career as opposed to the software development specific things.
Thanks. And I was also curious about, so it sounds like ODOT is a great partner, a great customer for you, and but I don't know how much you're looking to expand CASS, but what types of markets and customers do you see as potentially good matches for CASS? I mean, there's government, there could be private industries, there could be nonprofits. Do you have any thoughts along those lines?
Mark, I'm going to let you take that one.
Okay, sounds good. Yeah. So I think for us, there's a couple things that we want to consider when it comes to a project. We found that it's most straightforward for us to work with government agencies in particular, just because the intellectual property and contracting issues are much simpler when we work with government. I think, depending on where the intellectual property lives or is owned. So like, for example, working on an open source solution with, say, a nonprofit or a for-profit company would be possible because we don't have to fight that intellectual property battle as much. Where things get a little dicey is when there's proprietary technology involved and intellectual property questions. And that's a little harder for us to kind of work out from a partnership perspective. So typically where most of our partners tend to be, as I mentioned, government based or even here on campus. We do a fair amount of work, for example, for the Oregon Department of Environmental Quality as well as ODOT, and a few other state agencies we've done work for here and there. And then, of course, campus, we have various departments on campus that we work with, still, hosting and maintaining applications for them. So, I think it's a lot of it kind of comes back to that. And then the other thing we look for is it the technology or the solution going to be conducive to student learning? Somebody comes to us and says, hey, can you modify my Access database to have a new form on it? Sorry, that's not us. But if they come to us and say, hey, we've outgrown Access, we need to build a solution that, that actually, an application that's going to solve this need that we have. We see definitely good opportunity for students to learn there, then that's the kind of project that's going to be conducive to that learning, and we'll take it on. The other thing is that, just logistical project management things can be problematic. So we'll make sure that the project's not going to be on such a tight timeline, for example, that there's no way for us to get it done in time, considering we have part-time students working on it, right? Things tend to take longer. And so we want projects that are going to fit the kind of the student learning and development model.
Right. Yeah, that's interesting because you could have said, oh, we're going to take on those little form changing projects because any student can do that, but that, would not fulfill your mission. Yeah, I have a few ideas for interfaces that you could overhaul at OSU for certain systems. But
Happy to look at them with you. Yeah.
I won't name names. So yeah.
So something just really quick to jump in, Alan, an area that we have been growing in lately are supporting grants here on campus. So some of the research grants we find, for example, we're working with the College of Agriculture in their Applied Economics department, where they have a researcher who's got some great ideas around economics and big old equations, right? But he doesn't know how to put it into a model to actually execute it. And so we're working with him to figure out how to build that so that he can put his equation into something, spit something out, and actually get data that he can analyze. So stuff like that, it's really been fun growing and learning about some of the different things here on campus that we can help with.
Yeah, that's definitely yeah, I'll be keeping that in mind as well, because yeah, sometimes there are these just things that you don't want your grad students to work on necessarily, but they need to be done. Yeah. Well, it looks like we're right up to the hour. So yeah, thanks a lot. I have a lot more questions, but I'll have to get to you some other time. This was informative. We've got this recorded, so yeah, if anybody in the audience knows somebody that should have seen this, you can point them to it. But thanks a lot.
Thank you, everyone.
Thanks, Alan, for inviting us. We appreciate it.